Today's lesson continues with standard ASSE.4. We're focusing on the textbook Chapter 12, Lesson 3. It's the second day we've spent on Chapter 12, Lesson 3, which is about geometric sequence and series. Yesterday we learned about the format of what a geometric sequence looks like. Today we're going to look at a series, and that's when we will be adding a list of numbers together that are in the geometric sequence. So we will skip over the warm-up, just remembering that ASSE.4 is about arithmetic sequences and geometric sequences, and there are the subtle differences. An arithmetic sequence increases from one term to the next by the same fixed number, whereas a geometric sequence increases exponentially. And that is the key, exponentially. When you're looking at the two types of sequences, whether it's a geometric or an arithmetic, a geometric sequence will always have an exponent in it. The arithmetic sequence, for the rule and for what I'm showing you here now, the sum formula, how you add up the list of numbers in arithmetic, there is no exponent in sight. So we're focusing today on the formula to calculate the sum of a geometric sequence. And that's what we refer to this as a geometric series. It's when we're adding together. Well, you could pick up your calculator when you see the list of the numbers in the geometric sequence and add them all together, but that's not very efficient. What if your geometric sequence, for example, had 100 numbers in it? That would be rather time-consuming and a high probability of potential for error. So there is a formula that's been derived. In class, we would have worked on figuring out how you add together the terms. We could have self-discovered this formula for the arithmetic series. The geometric one is a little bit more complicated, partly because there's an exponent. So in this case today, I'm just giving you the formula. We'll work on how you simplify. But to find the sum of n terms in a geometric series, you take the first term times the quantity. Now in the numerator is 1 minus r to the nth, and the denominator is 1 minus r. So you have to think carefully about your order of operations. So you will simplify what's in the parentheses first. So once you see there's a lot going on in the parentheses, you then in essence start over with your order of operations, and you would evaluate the exponent, r to the nth. R is that common ratio, where n is the number of terms. You'd calculate that. You would then do the subtraction and figure out what your numerator is. You then simplify your denominator, 1 minus that common ratio. You then would simplify this fraction that's in the parentheses. And the very last thing you would do is to multiply the value you've simplified, what's in the parentheses. You'd multiply that value by the very first term in the sequence. Let's look at an example. So here's a very basic a geometric series. We remember the summation notation. It's asking us to find the sum of the first through the 16th terms. So you're adding together 16 terms. You really would not want to use this rule, this is the rule, to calculate 16 different numbers and then add them all up. It's far more efficient to use the formula. So don't forget, when you look at this summation notation, the 16 represents n terms, 16 terms. 4 represents the very first term, so they've just handed you the a sub 1. And the 3, the term that's being raised to the exponent, that is the common ratio. So they're telling you what n is, they're telling you a sub 1, and they're telling you r. So it's almost as if this is a little easier than an arithmetic series where you had to calculate the first and the last term and then substitute them into the formula. Here, they're giving you all 4 the variables that you need to put into the formula. You just have to be very careful how you simplify this. Because typically, for example, if you're taking a standardized test, they will not give you your answers as rounded decimals. You never would want to give an answer as a rounded decimal. You would want to give it as a fraction, or If it ends up being an integer, you can use the integer answer. So if I have any fractions, I'm going to keep them as fractions and not convert them to decimals. Many times that decimal will not be a perfect decimal. It's one that I do not want you to round it. So let's start our substitution. First term, a sub 1 is 4. 1 minus my common ratio of 3 raised to the 16th power is the numerator, and the denominator 1 minus r, which is 3. So now we'll carefully simplify. So in my calculator, could not have done this one in my head, 3 to the 16th power, would have calculated that, and then subtract that number from 1. So 3 to the 16th number is 43,046,721. You would have then taken 1 minus that number. Thus, you'll have a negative. It's pretty common you're going to have some negatives if you're taking 1 minus a number raised to an exponent. It most likely will be very, very large if indeed your r, your common ratio, is an integer. The denominator, 1 minus 3, again gives us a negative number. But don't assume we're going to have a negative answer here, because next step you'll take the negative divided by a negative. Again, you're simplifying everything in the parentheses, and then you can take that number, this positive number that you will get, multiply it times positive 4. So the sum of the first 16 terms in this geometric series that have a rule of 4 times 3 to the I minus 1, the sum of those 16 numbers is 86,093,440. So be prepared for very large numbers for your sums, or possibly fractional answers that'll be really small numbers that could end up being between 0 and 1. Let's take a look at one of those examples. So here's another summation notation asking us to find the sum of the first 6 terms in the geometric series where the terms are calculated 4 times 1/4 to the I minus 1. Again, I would not recommend that you calculate the first 6 terms and then add them up, because when your common ratio is a fraction, all of your terms in this case will end up being fractions, and it gets kind of complex. So we're going to identify, I want you to take a minute now, pause the video if you need to identify what is your first term, what is your common ratio, and how many terms will you be adding together. So I have identified here my number of terms is 6, my first term is 4, my common ratio is 1/4, and on my work paper I wrote down the formula, because after this point it really comes down to, I don't want to say simple, but it kind of is. It's basic substitution and some basic arithmetic. But when you're working with fractions, some of you will not feel like it's very basic, but truly it is basic arithmetic after you do your substitution. So now I've continued to show you the original problem, the formula. I've substituted 4 in place of a sub 1, 1/4 in place of r, 6 in place of n. In the denominator, I have the 1/4. This is where you need to be very careful with your order of operations. I would not be using a calculator at this point unless you're choosing to make sure you keep everything as a fraction. We do not want to round to decimals at this point. All answers for problems like this are always end up being written as a fraction. So the first thing I'm going to do is evaluate 1/4 to the 6th power. With my fancy TI-84, I do not have a fraction button, but I do know my exponent rules, as do you, that 1 to the 6th is 1. Then in my calculator, I could calculate what 4 to the 6th. In essence, you're taking 1 to the 6th power and 4 to the 6th power, and that will be my next step. I've evaluated 1 to the 6th is 1, and 4 to the 6th is 4,096. I also went ahead, because you can do this in your head, and simplified my denominator. 1 minus 1/4 gives me 3/4. My next step is to finish cleaning up my numerator. 1 minus that fraction. A lot of ways you could do it. Hopefully you can think logically about it and not have to put it in your calculator. But I would be thinking in my head of not writing 1 as the integer 1, but writing it as the fraction 4,096 over 4,096. Create that common denominator, and it's very quick and easy then to subtract your two fractions. That's what I've done next. Cleaned up the numerator. So 1 minus this fraction here gives me the fraction 4,095 over 4,096. Double check your work. Next step is to simplify this big ugly fraction that has a fraction in the numerator and a fraction in the denominator. I'd prefer to look at it as a division problem where this big fraction bar represents division. So I'm still in my parentheses, new page, and I'm taking my numerator divided by the denominator. So there's the original numerator that was simplified divided by the denominator. But you will now remember from middle school math, technically you can't divide with fractions. We will change it to a multiplication problem and we'll multiply by the reciprocal of 3/4. And that's what I show on my next page. I've changed division to multiplication and I've taken the reciprocal. Now again, you're going to be tempted to take out your calculator and multiply these two fractions, but it's far easier if you simplify before you multiply the fractions. 3 is a factor of 495. 3 will divide into 495. We can simplify. 4 is a factor of 4,096. We can simplify that. That yields, inside of the parentheses, is the fraction 1,365 divided by 1,024. Once again, don't be tempted to pick up your calculator. Think of this as 4 over 1 times that fraction. And 4 will go into 1,024. So simplify that first, and you will see that that product gives you the fraction 1,365 over 256. If you were to have given a decimal answer, your calculator most likely would have rounded it, and we needed exact. This is the exact and perfect answer, looking mathematically beautiful. So here's my final page that shows all of my work top down to give me the sum of those first 6 terms.